All right, so I thought I could pause that last one. It turns out I can't. So let's just do the nomenclature in a separate video. There are three molecules here. There's the original aldehyde, right, that we protected it, then we just got it back by aqueous hydrolysis. There's the product we got by adding a methyl grignard to the aldehyde, and there's the product of hydride reduction of the aldehyde. So nomenclature, just work out hit pause and work out what the names of these three compounds is. What are the names of these three compounds? I don't do anything. I haven't done this in a while. Okay, so hit pause, do that, come back. If you got your names, let's go ahead. I'm gonna start over here with the aldehyde, our original molecule. And it's important to count the carbons. Okay, so 6 carbons in a chain here. There's a 7th carbon on the methyl, so methyl coming off the 4 position. So this is going to be 4. I'm leaving a space there. I'll explain that in a second. So 4 methyl, 1, 2, 3, 4, 5, 6. For most aldehydes, the aldehyde carbon is going to be carbon number 1. And so this is going to be hexanal. Okay, so hexane for 6 carbons, and then al for an aldehyde. So again, let me make sure that's right. 1, 2, 3, 4, 5, 6. Yeah, the longest chain is 6 carbons. I've left a space here for the chiral center. So that methyl group is, the carbon with the methyl, the 4 carbon is chiral. So let's put all the groups there. Let's put 10 I want. If you didn't do the stereochemistry, you can stop now and try to do that. Stereochemistry is an important part of the name of any compound. Okay, so you're back. Assign priorities now. So H, carbon, carbon, carbon. When you do these priorities for stereochemistry, you always go one atom out from the chiral center at a time. Don't try to be like, well, that group's big, that group's second big. I think it's going to work out that way, but don't do that. So hydrogen is 4. I'll put the priorities in red. So low priority group is hydrogen. Carbon, carbon, and carbon all tie. Okay, so let's go, you have to go past them. So this carbon's bonded to a carbon and 2 hydrogens. That carbon's bonded to 3 hydrogens. That carbon's bonded to a carbon and 2 hydrogens. Okay, CHH ties CHH. The methyl loses, so the methyl is 3. Keep going. Next carbon, CHH, HHH. Okay, so this methyl loses to that CH2. So this is going to be 2, and this is going to be 1. I should say that's going to be 2. Again, the group is what gets the priority. And notice here, you might have thought because of this oxygen that was number 1. And it turned out to be number 1, but not because of the oxygen. You have to go 1 atom at a time. Okay, I've beaten that into the ground. So now we look down the chiral carbon 4 priority bond. So we put that H in back and we trace. With the H wedged back, we can just draw our circle. 1 to 2 to 3. That is I've said this in class. I always screw up clockwise and counterclockwise. That is counterclockwise. Okay, so that's going to make this an S chiral center. I really should have checked this before I went on video. I'll check it, I guess, before I upload it. But again, if priority 1 is here, priority 2 is there, priority 3 is there. The H is straight back. So if you imagine the carbon here with the H going back, we've got 1 up here. Sorry, that's not, it's coming off the, so we're looking on that carbon, yeah, that's right. 2, 3, yeah, that's S. So the only way I could have screwed this up at this point is if I got the priorities wrong, and I'm pretty confident I didn't do that. So anyway, that's an S chiral center, and so S has to go in the name. So the name is going to be 4S methyl hexanal. Now, if you go do the alcohols, notice that we never do any chemistry on the chiral center, right? All the chemistry is taking place on the aldehyde carbon. We had a methyl in there, we had an H in there, and so it's going to be 4S. Well, it's going to be S in all of these. So 1, 2, 3, 4, 5, 6. So 4s methyl, and now 1 hexanol. All right, it's only one letter difference. All for an alcohol versus al for an aldehyde. The chiral center 4 stays the same. Okay, now do the secondary alcohol that we get by adding methyl in. Clearly this now is going to have one more carbon. 1, 2, 3, 4, 5, 6, 7. The chiral center is now carbon 5, but it is still S because we haven't changed anything about the priority bonding here. So this is going to be 5S methyl, and then 2, because now the OH is on carbon 2, and carbon 2, sorry, this is going to be 1, 2, 3, 4, 5, 6, 7. So this will be heptanol. So 5S methyl, 2 heptanol. Now, last thing on this problem, what is the chirality of carbon 2? Right? Carbon 2 is a chiral center. There's an H there, an OH, a methyl, and the rest of this thing. So that's 4 different groups on carbon 2. That is a chiral carbon. I haven't indicated that in the name, and the reason is when the methyl adds in, so methyl Grignard is going to add in here. That's a really lousy H. There's nothing to control that. This methyl group, this chiral center out here might have a little bit of an effect, but it's pretty distant. That's a very reactive nucleophile. That methyl is really going to add from the top and from the bottom pretty much equally. And so this is going to be a mix of diastereomers. Right? So you're going to have R and S at carbon 2, and you're going to have only S at carbon 5. So that S pair is a diastereomer of an SR pair. And you don't have any RR or RS. Okay, those are the names.